Hello, this is lesson 7.6, dealing with more right triangle. Let's start with looking at this first problem on the notes. Again, we're asked to see if we can find this value z, and this is the hypotenuse. Remember, it's the longest side across from the right angle. And again, if I knew this, I could use a Pythagorean theorem. But since I can't, so I can't use a Pythagorean theorem. Second thing, I have this is opposite, that's good, and I don't have the adjacent here, so I can't use the tangent function. So we have to have another way to figure this out relating these items here. So I need something that relates this with this and this. And we do in fact have a function that does this. So looking down here at our essential question, how can you find the lengths of the legs of a right triangle when you are given the length of the hypotenuse and one acute angle? And again, kind of not exactly the item here, but we do have two other functions in trig. So use other trig, meaning trigonometric functions. Okay, and we have either the sine function, which we use sin, not sin, but sine, and then we have cosine, and that's cos. Okay, so let's continue here. So the sine function of an angle A is going to be the opposite leg over the hypotenuse. And then the cosine function is going to deal with the adjacent leg to the angle A compared to the hypotenuse. So these are very similar. We call this sa, and then we have co. So this goes along with the tangent mnemonic device here. So as we said here, we have these items here. So the sine ratio, and again I have that abbreviated as sin. And again it's opposite leg over the hypotenuse. So looking at A1 here, if I'm doing the sine of x, here's the opposite, and here's the hypotenuse. So I'm going to say the sine of x, big X, equals 15 over 25. I can divide out 5s and get 3/5, and then the decimal for that is 6 with some zeros after it. If I go ahead and do the second part, so if I'm doing the sine of big Y, if I'm up here, here's my opposite now. So it's going to be 20 over 25. Take the 5s out, and I get 0.8000. Moving on. Typical type question here, just like our tangent ratio. I've got an angle, I've got the opposite, and I've got the hypotenuse. So this is not TOA. This is going to be that ratio. So we're going to say the sine of 47 degrees over 1 equals y, little y, over 12. So like before, we're going to go ahead and do a calculator operation here. So hit the sine button, sin, 47, and we should get 0.73. That's probably good enough. Then we are ready for our proportion work. Multiply my numeric values diagonally and divide by that. So we get y equals 0.73 times 12, which is going to be 8.76. I know it says tenth, but I did some extra. That's okay. Alrighty? Typical type problem. Moving on here, A5 is another problem dealing with the sine ratio. So let me switch back over to the blue. And I have the sine ratio. So again, we're looking at opposite over hypotenuse. Here's my angle, and here's my opposite. And oh boy, I can't use this here. So let's kind of hold off on this problem here, and let's kind of continue with the lesson here. So let's kind of skip that slide here. So again, now we have this other function called the cosine. And again, cosine here. So cosine is going to be the adjacent over the hypotenuse. So we call that ca. So again, if I'm going here, so cosine x is going to equal the adjacent. So here's x, here's the adjacent, the ADJ. So that's going to be 20 over 25 for the hypotenuse. Divide out the 5s, I get 4 over 5, and that's going to be my 0.8. If I go ahead and take a look at the next one here for the cosine y, so cosine big Y is going to be, so here's y. Now here's the adjacent in reference to that angle. So I get 15 over 25, which equals, after dividing the 5s out, and gives me that. So very similar to the sine, except we have a different kind of combination here. Okay. Now if we go back to this problem here, we're actually not going to use the sine ratio because I have an angle, I have the adjacent leg, and I have the hypotenuse. So if I'm looking at tangent, I'm looking at sine, and I'm looking at cosine because the Pythagorean theorem doesn't work. Can't use that. Can't use that. I have to use this one because I have the A and the H. So I'm going to say the cosine 39 degrees over 1 equals 44 over G. So again, looking up cosine, hitting it on the calculator, COS, and then 39, I get 0.78, okay, for that. Then I switch over to do my proportion work. I get that multiplied, divide by that. So I get G equals approximately 44 divided by 0.78. And I get 56.4. No units on here for my answer here. So that wraps up the kind of normal problems here with sine and cosine. Now continuing, a lot of real life problems talk about angle of elevation, which is looking up from the horizon, okay? And the angle of depression is looking down. So again, you can see up above here that there is a difference, but since these are parallel, these angles will be the same using parallel lines. So let's do a couple problems dealing with those type of references. So now moving on to this problem here, we have find the distance from the observer's here, to the rocket using an angle. So I'm looking for this. Elevation of 31 degrees. So this is 31 degrees because it's angle of elevation. So this is an angle up. The rocket's taken off perpendicular to the ground, and we have that. So now we can go ahead and say, hey, we have an angle of interest. We have the adjacent, and we're looking for the hypotenuse. So in my SOHCAHTOA, I'm using the A and I'm using the H. It's cosine. So I'm going to say, hey, cosine of 31 degrees over 1 equals the adjacent length over the, I'm going to just use question mark. Again, I'm going to go ahead and find cosine of 31 on my calculator. So that's 0.86 is a good approximation for that. And now we can do our normal proportion work, multiply those guys, divide by this guy. So my unknown is going to equal 5.2 divided by 0.86. And we get about 6.05 kilometers away. Alrighty, so again, the key thing there is we had an angle of elevation. We had to put that, and we had to determine which length we were looking for. Once we had that, we used our SOHCAHTOA to figure out which trig function we use. One last problem to do here. You are skiing on a mountain with an altitude of 1,200 meters. The angle of depression, so the angle down is 21 degrees. And again, that means this has to be 21 degrees. So let's make sure we get that written in here as well, because of this angle is congruent to that, alternate interior angles as well. We are looking, if the altitude is 1,200 here, it's 1,200 here as well. And we are looking for this. So we've got these three pieces. So I've got an angle, I've got the opposite, and this is the hypotenuse. So again, if I do my SOHCAHTOA, I have O and I have H, and that's going to be sine. So I'm going to say, hey, it's the sine of 21 degrees over 1 equals the ratio of opposite over hypotenuse. Again, sine of 21 on the calculator gives us 0.36. And like I've done in the past here, switch to red. Here are my multipliers. Here's my divisor. So I'm going to get 1,200 divided by 0.36. And lots of threes here, so x equals 1, 2, 3, 4.3 repeating, and we're talking feet. So again, that would be the length of your ski run, which is more than half a mile, so that would be kind of a nice bit of skiing there. So again, working on this lesson, the main things are going back here so that we're using two new functions to solve these right triangle problems. Good luck with your assignment.